This conference will now be recorded.
Hello everyone, my name is Wagner-Bielefeldt. I will present the paper Evaluation of Thermodynamic Simulation, FactSage, for the interpretation of the presence of phases and the firing behavior of triaxial ceramics. This work is taking part of doctor thesis of Lindsay Baccarin, and I will present the paper on GTT users meeting 2021. Triaxial ceramics comprise a variety of products such as floor tiles, tableware, sanitary ware, between others, which represent a large part of the productions of the ceramic industry. They are manufactured from a group of raw materials, mainly by kaolin clay, feldspar, and quartz. Although the production routes may vary, they all end in a firing stage to consolidate the final properties. Given the complexity and number of variables that influence the firing of white whales, a direct relationship between the thermodynamic study and the final properties of a part is not expected. Nevertheless, thermodynamic analysis can contribute to the understanding of some variables, mainly the relationship between chemical composition, initial temperature of vitreous phase formation, and the type and proportion of the final phases. In order to evaluate quantitatively the effects of heat of kaolin, feldspar, and quartz triaxial system, the FactSage software, the version 7.3, was used in this research. The thermodynamic stable phases present in the raw materials were investigated and, at different temperatures, the formation of the liquid phase and the crystallization of the mineral phases were analyzed, as well their quantification. The simulated data were compared with the results of the experimental analysis. So, the methodology first was the formulation of triaxial ceramics, 50% of kaolin plus 25% of feldspar plus 25% of silica. It is the most used proportion of these components on triaxial ceramics. After that, we use the FactSage to calculate the phases formed at room temperature of the raw materials, and after that, the system of triaxial porcelain system. And after that, I will show the results and some discussion. Here in table 1 is possible to see the chemical composition of the raw materials and the triaxial composition by X-ray fluorescence. Here in this table is possible to see first the analysis of raw materials kaolin, X-ray diffraction, FactSage, and rational analysis. It's possible to see a good agreement between results from FactSage and rational analysis, but the main phases are different between X-ray diffraction and FactSage. In general, kaolin has kaolinite as its main phases and not the polymorph dicrite. The lower rate of activation energy for the formation and growth of kaolinite crystals is the factor of the predominance of this phase in natural environments over the more thermodynamic stable phase. X-ray diffraction analysis of kaolin presents ilites as the secondary phase, while FactSage indicates muscovite. Again, it is explained by the greater thermodynamic stability of muscovite. Here is possible to see the analysis of Feldspar. In general, the results agree between FactSage and the X-ray diffraction. For the Feldspar, the main phases identified in FactSage and X-ray diffraction were the same, Micocline and albite. However, FactSage showed a low value of corundum and a compound of calcium and sodium aluminate, which are below the detection limits of X-ray diffraction analysis. The simulation in FactSage always point to structures with greater thermodynamic stability, which do not necessarily correspond with the actual composition of the phases of a raw material. This occurs due to the complexities of the geological process in the formation of a rock and in the crystallization or transformation of a mineral. These are essentially determined by the process kinetics and variations in local composition, in addition to temperature, pressure, among others, which vary during the mineral formation process. In accordance with the above description, the quantitative analysis presented by FactSage shows yet another limitation when used to investigate raw materials that have undergone intensive milling. This process, in general, leads to the formation of amorphous phase, so that the levels of crystalline phases indicated in FactSage will always be higher than the real ones, since only crystalline phases are considered in the calculation of the phases content at room temperature. Also, here is possible to see the analysis of quartz. X-ray diffraction and FactSage agree very well. Here is possible to see the phase evolution and solid-liquid transition in relation with temperature of the Triaxial Ceramics. The calculated data was made by FactSage. Here is possible to see on the horizontal axis the temperature in degrees Celsius. The vertical axis is the mass percentage. It's possible to see the evolution of the liquid phase, LP, the evolution of mullite, M, and the evolution of tridymite. At 1930 degrees Celsius, the phases presented are tridymite, feldspar, and mullite, with the amount of liquid phase still incipient. Thus, it can be considered that the melting of the feldspar did not occur significantly at this temperature, and tridymite, resulting from the polymorphic transformation of quartz, was practically unchanged by heating. The disappearance of kaolinite means the formation of mullite and amorphous silica, going through the reaction of metakaolinite as shown on the two reactions below. Metakaolinite transforming in mullite and water. Okay. Here in this table were made analysis of between papers on literature, Norton, Martins Vasquez, Marinoni, the average of these results and the results of FactSage. In general, it's possible to see a good agreement between the main components as kaolin, quartz, feldspar, but more disagreement between the results of mullite and glass phase. This is a quantitative phase analysis after firing and at 12,000 degrees Celsius. Calculated quartz content is the furthest from real data. Here we have the FactSage, where happens intense solution in simulation versus experimental solution depends on initial particle size. And diffusive process kinetics have a strong influence on the solution reaction. Although the mullite is continually dissolved in the liquid phase simulation, depending on the experimental conditions, the simulated and real values can be close. In practice, however, the mullite first increase in quantity and only decrease at very high temperatures. Mullite crystallization is a phenomenon that depends on process kinetics and equilibrium conditions. The main conclusions. FactSage can be an alternative as it enables the calculation of multiple components simultaneously. However, the use of the software requires some care, selection of input variables, evaluation of calculated phases. The phases predicted in the raw materials did not always agree with the actual phases indicated in the mineralogical analysis and cannot accurately predict the phases present at room temperature. However, by indicating the possible phases formed under real thermodynamic conditions, it can be an opportunity not only to the study of rocks, but also of synthetic materials. The low melting temperature of feldspar is explained by the fact that FactSage considers a multi-component system. FactSage considers practically all silica. It means quartz raw material plus amorphous silica from kaolin decomposition as tridymite, which does not allow differentiating the amount of amorphous silica from kaolin during the formation of the first liquid phase of porcelain. Although the microstructure of triaxial systems depend on diffusive process kinetics, by using higher firing temperatures, longer times, and smaller particle size of raw materials, mainly quartz, simulated and practical data have become more mixed. Thank you so much for the opportunity. I have to say that this work is accepted for publication in Ceramics International. I am available to answer any doubts. This work was doctor thesis of Lindsay, and please, people are free to ask, and I can send some questions to Lindsay if in fact she has more knowledge about the subject. Thank you so much, GTT, for the opportunity. Thank you.